and I'll be walking through all my slides. First of all, the other factor, like the other important role of machine learning is it enables automation and efficiency. When it comes to machine learning, these algorithms are able to automate credit evaluation process, which in time which saves time and resources compared to the traditional available manual methods. And automation reduces the chances of human errors as well, which enables quick and consistent decision making and hence accuracy. And with machine learning, still we are able to have a continuous learning process. Like you get a module, and this module is designed to adapt to the new changing patterns, like the new changing financial landscapes which are available, and the risk factors which are keep on changing. And the other is risk management, like risk segmentation. With machine learning, you're able to group different borrowers depending on to their financial statements from the previous transactions carried out by them, and you're able to know who is able to pay and who is not able to pay the amount they borrowed. And lastly, with fraud detection, like with machine learning, you're able to detect fraud, and this algorithm can be utilized, like the machine learning algorithm can be utilized to identify patterns indicative of fraudulent activities, and which in long run like adds on an extra layer of security to the credit assessment process. Well, for the next slide, well, I'll be walking through all the definitions for these different paradigms of machine learning. And first of all, we'll be looking at supervised learning, and this involves typically training a module on a given dataset, and this module is able to you map it to corresponding outputs, and the module learns the mapping between the input features and the target label, and it will be able to give you a prediction whenever you subject to it a new data set. And such algorithms for this supervised learning, we currently have classification, regression, and regression algorithms. The second one is unsupervised learning. With this, we deal with unlabeled datasets, and where algorithms are tasked to find their own patterns and relationship and structure within the input data, and without guidance, they're able to tell the output, and and this helps us to discover hidden patterns of the data set. Lastly, it's the reinforcement learning. This involves a system, like you train a system learning to make decisions by interacting with the environment, and the system receives feedback in form of rewards or penalties based on based on different based on its actions. And the goal for the system is to learn a strategy or policy that maximizes cumulative reward over time. And for such algorithms, we have the Q-learning algorithm and the Q-network algorithms, and there are so many other algorithms available, but for this I'll be looking into only these, the Q-learning and the deep Q network algorithms. And the major differences between these paradigms, when it comes to data labeling, for supervised learning it uses labeled data, and for unsupervised it uses unlabeled data. Well, for the reinforcement learning, it does not require explicit labeling, but requires own rewards and penalties for its actions taken. And lastly, and for the other differences, when it comes to tasks, for supervised learning predicts output labels, and for unsupervised learning discovers pattern relationships and structures in data by its own. Hence, it discovers hidden patterns. And for the and for the feedback case, with supervised learning, it receives explicit feedback in form of labeled examples, like the feedback it expects should be a labeled data. And for unsupervised learning, learns without explicit feedback, like focuses on inherent data structure, like it doesn't expect anything like as a feedback, maybe like for the case of supervised. And for reinforcement learning, receives feedback in form of and rewards or penalties based on its action taken. Well, assign a credit score, which indicates the borrower's credit worthiness and predicted default probability. And the other is loan approval. Like banks use modules to predict the risk of loan of each loan application and make informed decision about whether to approve or deny a loan. And the other is early warning system. Modules can identify borrowers at high risk of defaulting before they actually miss a payment, allowing the proactive intervention and potential preventing defaults. And for example, examples of algorithms are modules for credit risk assessment. Here for supervised learning, we have logistic regression and the SVMs, which SVMs find a hyperplane that best separates borrowers who defaulted from previous loan and those who didn't, which is effective for high-dimensional data but can be computationally expensive. And for logistic regression, a classic algorithm that models the probability of default as function of a borrower, the function of a borrower. Well, the problem solved by supervised learning. Supervised learning tackles two main problem types in credit risk assessment, and with classification, predicting whether a borrower will default on a loan, yes or no. This is typically the case for credit scoring and loan approval decisions. And for regression, predicting the expected loss amount if a borrower defaults. This can help banks estimate the potential financial impact and make informed risk management decisions. And labeled data utilization, here it's all about the quantity and quality of labeled data. Significant, like the quantity and the quality of labeled data plays an important role in the performance of a trained module. And for the next paradigm, the unsupervised learning paradigm, here like an algorithm is designed without any instruction on what to do, and you just have to subject it to a data set and it will find its own pattern or group it and define its own structure of the data and make predictions like accordingly. And examples of such algorithm, we have clustering, dimensionality reduction, and association. And the application of this in credit risk assessment, like with unsupervised technique, this can be applied to analyze patterns within the data without the need for the labeled instances of good or bad credit. This can help to identify the hidden trends and potential risks that may not be apparent through traditional methods. And examples of such techniques we have like algorithms or techniques planned for this case of unsupervised learning. We have clustering, dimensionality reduction, and association. And for the next slide, we look into insights or patterns of unsupervised learning. And first of all, we're looking at risk segmentation, identifying segments of customers with similar credit risk profiles. And the other is behavior patterns, uncovering hidden patterns in behavior of individuals that may be indicative of credit risk. And lastly, is correlation, understanding the relationship between different financial indicators and creditworthiness. And how are we able to handle unlabeled data? Well, since unsupervised learning deals with unlabeled data, an algorithm is designed to explore the data structure without predefined outcomes. The challenges underlining this is interpreting the discovered patterns and determining the relevance to credit risk. And lastly, among the three paradigms is the reinforced learning. Here it's all about training, like training a module by interacting it with the environment, and it receives feedback from the environment in forms of reward or penalties. And illustration for this, consider the example of training a computer program to play a game. The agent is the program, the environment is the game world, and actions are the moves the program can make. And the rewards are the points it earns. The losses are based on its move. Through trial and error, an agent plans to make better moves to maximize its score over time. And I'm planning to integrate this into my project, like trying to integrate this with my project to compare them. When it comes to environment, in the context of credit risk management, the environment represents the financial landscape, including various factors influencing credit risk, market conditions, economic indicators, and borrowers' behavior. And for the agent case, the agent is the decision-making system employed by the financial institution to assess and manage credit risk This could be a computer program or algorithm or any module responsible for making decisions related to the lending and credit risk system. And the reward system, like for the case of credit risk management, it's based on outcomes of credit risk decisions. Positive outcomes such as timely repayments and low default rates yield positive rewards, while negative outcomes such as default, late payments, and high risk exposure result into negative rewards. Um, like the potential use cases in credit risk assessment when it comes to reinforced learning, like decision making process. With the reinforced learning, we can be able to optimize decision making in credit risk assessment. The agent dynamically adjust lending criteria based on changing market conditions, borrowers' behavior, and economic indicators. And the other is optimization problem. With the reinforcement learning paradigm, we are able to, it's applied like to optimize credit risk management strategies. For example, agent can learn to allocate credit limits effectively and balance risks and return adapt returns and adapt to its lending policies to minimize the overall credit risk exposure. And lastly is fraud detection. Like with this paradigm, it contributes to credit risk management by enhancing fraud detection algorithms. The agent learns to identify patterns associated with fraudulent activities and adjust strategies to mitigate the risks. And like the comparative analysis for all these paradigms, well, with supervised learning, or already know the definition, like application, like the application of it in risk assessment is like we're going to use this to tell you're going to use this paradigm to tell the likelihood of a customer or a borrower to default on a loan or not. And the advantages of it is it's effective when there is a clear distinction between positive and negative outcomes. It's well suited for classification problems. And for the disadvantage, the major disadvantage of this, it requires labeled data for training, and obtaining labeled data for credit risk assessment can be challenging. And unsupervised unsupervised learning, like the credit risk assessment application, like how are you going to implement this in the credit risk assessment project. um, with unsupervised learning, this can be used this can be applied to segment customers into different risk groups based on their financial behavior and their credit history without predefined labels. And the major advantage of this is it's useful for hidden pattern or grouping within the data. And the major disadvantage of this is lack of labeled data might limit the interpretability of the results and algorithm pattern that may not directly be relevant to the credit risk system. And continuation of comparative analysis, we'll be looking at the reinforcement learning.